Hello guys, welcome to this new video. In this particular video, we are going to talk about matrix operation. Hopefully, you guys have already checked my last videos where we discussed about some of the introduction of linear algebra. Then we talked about some of the vectors operations. Now we are going to talk about something called matrix operation. So we already know what a matrix is, right? So if you have a matrix like 1, 2, 3, 4, this is a 2 cross 2 matrix. That means m rows n columns, which is 2 and 2, right? That is what it means, right? So in matrix, we can think of matrices like if we want to do some transformation in a machine, we want to do transformation through something like points, through vectors, through shapes, or any kind of data transformation, right? So in matrix, your first operation should be something related to matrix addition, okay, which is called addition. Okay, what is addition means? So if you'll be taking an example, same a is equals to 1, 2, 3, 4, and your b is equal to, it's a matrix, okay. So the b is equals to 5, 6, 7, 8. If you'll be looking closely, these are 2 cross 2 matrix, 2 cross 2 matrix. So if you will be doing a plus b, which is nothing but addition operator, is nothing but you will try to add all the respective elements respectively, okay, respective position element. So if I'm talking like that, then what does that mean? 1 will be added to 5, 2 will be added to 6, 3 will be added to 7, and 4 will be added to 8. If you'll be looking closely, this result will be giving you 6, 8, 10, 12. Both are also a 2 cross 2 matrix. This is also a 2 cross 2 matrix. Okay, so what we are trying to do here, okay, so we are trying to do means what? If a is doing some kind of, if a, I will be saying a is doing some kind of effect and b is doing some kind of effect, we are trying to add them to make a single effect. So let's take an example to get a better idea. So what is the example I'm talking about? If I'm talking about a matrix like A is equals to, let's say 2, 0, 0, 0, I'm saying it, a robot, okay, I'm just saying it, a robot is moving, is getting a command, not moving, it's getting a command, to move horizontal direction, okay, to move in horizontal direction. So if I'm saying this one as a and I'm saying b equals to 0, 0, 0, 3, which is nothing but same a robot is getting into a movement of horizontal, named vertical, okay, vertical direction. If I'm saying horizontal and vertical direction, their sum is nothing but, I'm directly writing it down, you can know how I'm writing it, right? 0, 0, 0, 3, 2, 0, 0, 3. So now here you can see what is happening. That means my robot is moving horizontally as well as not moving, I'm just talking about getting commands, right? I'm saying getting commands, okay, getting commands horizontally and vertically, plus vertical commands, right? Getting commands. So I'm saying those two effect is happening respectively. That is what addition means. So then how will be going into subtraction? Similar concept, right? So subtraction will be same concept. If I'm a, I will be doing subtraction with b. So my a used to be something like this, right? My a used to be 1, 2, 3, 4. B used to be minus 5, 6, 7, 8. If you are doing a minus b, is nothing but minus 4, minus 4, minus 4, minus 4. Hopefully you are getting it correctly, right? Because we're just taking a random number, so it is coming like that. If you'll be doing b minus a, is nothing but 4, 4, 4, 4. You can do it reversibly, right? Vice versa, right? So if you are taking something like this, if you will be doing in a proper way like the robot is doing, so let's take an example. in this case we are having two camera. Okay, let's imagine like having two cameras. Okay, two cameras, and with two cameras are having from different kind of measurement, I will be saying. So you think like you are standing here. Okay, you are having a camera here. Okay, camera 1. Okay, and the camera 1, camera 2 is here, camera 2, right? Camera 2. So the distance from this camera to this camera from you, okay, let's say d1, and this is, let's say, d2. Okay, so what I'm trying to say is you are having two camera which is having same measurement from you. I'm not saying I'm saying measurement, mostly I'm talking about distance. Let's say, okay, let's say I'm saying my a is equals to 180. Okay, 180, and my b, this is a camera 1, right? Camera 1 is equals to camera 2 is equals to, let's say, b is equals to 95 and 75. The moment I'm saying how much difference they are right now, okay, the difference between two, right? What is that mean? So if I'm saying, if I'm doing a subtraction, that means the error or the displacement between two measurement. I can say if I'm saying a minus b are nothing but what is happening, it is 5 and 5, right? So this is probably what I'm trying to say is it is the error or kind of displacement, I can say displacement between two measurement. Yes or no? Because initially what I told you like they are in same measurement. That is what I told you, na? I told you like they are in same measurement. Now after calculation, after doing the distance, it should be 0 0, but it isn't, right? If it isn't 0 0, it means it is error. This is pretty much understandable. If that is the error, that way we can use this subtraction method to find out the real difference between two objects, right? Okay, great. That you got to understand where the real world implementation is going to be. So what about my next kind of operation, right? Matrix operation. So let's say it is scalar multiplication. Scalar multiplication. What is scalar multiplication I am trying to do? I am saying whatever your matrix currently right now, you want to visualize, like let's say if you want to extend it in certain direction, right? Because scalar is nothing but a constant value, right? It's a number. A number can be positive number or a negative number. So according to that, your value changes, right? Your direction changes, your like distance changes from that particular point to another particular point. How it is possible? So we already know if a matrix I'm writing, okay, why I'm writing in a 2 cross 2 matrix always is because 2 cross 2 matrix is very easy to represent and very easy to calculate as well. You can take 3 cross 3, you can take 4 cross 4. It's just like 2 cross 3 is actually easy to do it, and I will be saving so much time in calculation. So if I'm writing something like this 1 2 3 4 and it's a 2 cross 2 matrix, what I'm trying to share is if I'm taking a scalar value k equals to 3, that means I'm doing a multiplication of 3 into it's a scalar multiplication of matrix, right? So if I'm writing this into 1 2 3 4, it's nothing but this 3 has to be multiplied into every possible position of that matrix. So it will be 3 6 9 and 12. This much clear? If this much clear, I can say the strength or the transformation you have done, okay, during this, what does that mean? So if I'm talking something like this, okay, I don't want to do it, I don't want to do tell you, right, how the scaling is working. It's just I'm trying to say here is like think about the point is here, okay. Normally the point means what? It's a vector, right? So if you are having a vector like this, if you are having another vector like this, and those two vectors, okay, these two vectors are now this point. If you want to multiply plus 3 with it, right, that is a plus 3 multiplication. So I will be multiplying with 3 now, Okay, this will be multiplied by 3, so it will be stretch a little bit, right? You can see this is stretching a little bit, this is also stretching a little bit. That is what it meant. Okay, that means the transformation is happening, the transformation is happening scale. So scalar multiplication is nothing but look the thing, why I'm trying to do here, what I'm trying to do here, if you'll be looking closely, this is what, this row is nothing but a vector, this row is nothing but a vector. So if I'm trying to say this is my x-axis, this is my y-axis, the point initially is 1 2, okay, the point here is 3 4. It's not correct way to do it. Maybe I didn't do it correctly, to be honest. If you want to do it properly, let's do it properly. Okay, let's do it properly. So if let's say if you want to do something like where it is, okay, so what is the 3 4, right? 3 4 3 4 3 and something like 1 2 1 2, okay, 1 2 3 4, let's say somewhere around here, somewhere around here, let's say. Okay, so now I'm drawing a line here, I'm drawing a line here in a 2D space. I'm trying to draw, right? And you will try to, try to like spread how much, you'll try to spread how much, 3 in each line, right? So 3 will be, this is something like this. Okay, something like this you can say. So now if this is the case, I can tell na something key, like this particular scalar multiplication is happening to scale the matrix, right? So this is called scalar multiplication is equals to nothing but, I can say, scaling. The transformation is called scaling. Just remember this term, scaling. We do lot of scaling. Okay, we mostly do lot of scaling, because you know what, you will have a data set, right? When you will have a data set, you have to scale it at certain point of time. You need to scale it. If you are scaling it, they will be saying, okay, if you are scaling it properly, then the data will be represented properly and your calculation will be done properly. Okay, so I what I am trying to say is, like, whatever you are trying to multiply, whatever you are trying to do, it's kind of a scaling. So now if this is you are getting currently cleared, we'll be moving forward with our next one, which is called matrix multiplication. This is pretty important. So there is a joke, or there is a meme on internet about matrix multiplication. It's like, whatever you are seeing right one, like, people are losing a lot of jobs, right? There are a lot of people who are losing jobs. They are saying like everything is happening in ChatGPT or Claude. It's all because of matrix multiplication. There are words which are getting multiplied and finding out a new kind of words are getting multiplied and finding out something new, and the blogs writing, all those things, like the the way you are asking questions and getting response with a bigger picture. They are saying that's why you are losing jobs, and they are nothing but a matrix multiplication, right? So this is one of the most important linear algebra concept. Very important, most important. Okay, linear algebra concept. Okay, so in AI I am talking. Okay, so what is matrix multiplication? So if you'll be looking closely, if I'm having a matrix like this, 2 0 0 3, and having a b vector, a matrix is nothing but 1 2 3 4. So what a b is going to be doing, it will be taking 2 0 0 3, it will be taking 1 2 3 4, and it will be trying to multiply. So how multiplication will be doing, you will be taking one particular row, multiplying them with this, adding them, and kind of summing them. How it is going to be, I will be showing you, okay, one by one. So it will be t cross 2 cross 1 plus 0 cross 3, then again this one with this one, right? So it will be 2 cross 2 plus 2 cross 0 cross 4, sorry, 0 cross 4. Now your second time will be this particular row with this particular column. So the values will be, so again this particular, again this one with this one. Okay, so what is that happening then it will be 0 cross 1 plus 3 cross 3, again 0 cross 2 plus 3 cross 4. So it will be calculating and doing summation properly. It will be 2 1 2 2 2 2 4 4 0 3 3 9 yeah 12. It's also a 2 cross 2 matrix. So if you'll be looking closely, it used to be a 2 cross 2 matrix. It used to be a 2 cross 2 matrix. Always remember, there is a catch to here. Always remember this and this has to be same. This has to be match to have to multiply two matrix. Okay, to multiply two matrix, this has to be matched. So I'll have a m cross n matrix, which is A. Another one should be B, should be n cross P matrix. Then your AB would be m cross P matrix. Hopefully you guys are clear. This is not that much of difficulties. So what we are trying to do here, I'll be giving you a very good example. This is pretty famous example. Okay, so if we'll be looking closely, I'm taking everyone in this whoever watching this video, they will be doing some kind of editing, right? So if you are doing, let's say, Windows Photos editing, okay, we are doing Windows Photos editing, photo editing. While doing Windows photo editing, what we are trying to do here is, if I am doing first I'm trying to do, I'm doing rotate the image. I'm rotating the image. Okay, I'm rotating the image. Then what I'm trying to say, I'm saying, okay, do scale the image. Now I already told you what is scaling means, right? Scaling means doing some kind of matrix multiplication with a scalar. So if you will be looking closely, the combined transformation, what will happen if I'm trying to combine them? So this is my combined transformation. Matrix operation are nothing but transformation, right? So if I'm doing combined transformation, the transformation would be AB. So that AB is nothing but, it's a chain of transformation. The first transformation will rotate, then you have to scale the image. So chain of transformation. Look at this, these terms are really nice, right? You are getting to know what is happening in the real world as well. So if you are doing scale of transformation or chain of transformation, in a simple term, if you will be looking closely, okay, this is clear. I don't want to do it because the matrix multiplication part I already did it, right? I don't want to do it again, the matrix multiplication, but this is a mostly example of real world, how these things works in real world as well. So if you will be looking closely, this matrices are nothing but the pixel thing. Okay, each pixel, the images are nothing but combination of pixels. Okay, combinations of pixels. So you are trying to you are trying to convert those pixel things. Okay, so if you will be thinking little bit deeper, if you guys already have seen some diagrams like this in neural network, okay, you'll be seeing lot of neural network like this, right? In neural network, okay, what we try to do is, like, there will be summation, there will be something called activation function, then there will be output to it, right? In neural network, what we mostly say is, like, this is my x1, x2, x3, x4, these are my input. Every input will have associated weights to it. Okay, and at the summation point, what we are trying to do is nothing but xi into wi multiplications, right? And the moment I'm saying this is my z, what I'm trying to say here is my z is equals to summation of xi and wi multiplication plus b, right? This is mostly z means. Then this z will be going from something called activation function. If you will be putting this z value activation function, you will be getting output, right? That is what mostly happens in neural network, and neural network is the base of whatever happening in AI right now. So if you will be looking closely, the w itself, the w, this w part, if I'm writing, if I'll be writing properly, so z is nothing but w x plus b, yes and no. So if you'll be looking closely, the z is also a matrix, the x is also a matrix. X is a matrix, w is a matrix. The w matrix transforms. So w matrix is nothing but weight matrix. I'm writing it down, weight matrix. So and the x is nothing but my feature matrix, feature variable matrix. Okay, if you haven't heard about these terms, don't worry. At some point of time, if I'll have times, I'll be trying to covering up the machine learning and deep learning concept. At that point of time, you'll be getting know what is feature means in dataset. Okay, it's just column. Okay, so if I'm saying something like that, I am these weights are actually nothing but it's mostly constant values. Okay, constant values, the proper word will be coefficient values. Okay, so if you'll be having a values of coefficient which are mostly constant, the x is also a kind of constant because we are trying to change words into vectors. So what I am trying to say here, the weight matrix transforms what? The weight matrix transform the input vector x, because this is if I'm writing small x, it's a single vector. If I'm writing a capital X, it's a matrix, because combination of vector is a matrix. So it is transforming one matrix into one matrix and multiplying with another matrix is actually nothing but transformation. Any doubt? So matrix multiplication is nothing but transformation after transformation, right? So matrix multiplication is nothing but transformation after transformation, pretty easy concept. The thing is like you should be able to look, kind of link everything properly. Otherwise learning mathematics is simply feels like you are doing whatever you used to do in math 12th and 10th, right? There is no fun to it. Okay, and then once it will be going, you will be going to some another matrix concept, operation concept is called matrix transpose. If you'll be knowing matrix transpose properly, it is very fun. So what matrix transpose is, if I'm having a matrix like this, which is nothing but 1 2 3 4 5 6, these are 2 cross 3 matrix. What A transpose is gonna do, A transpose is nothing but it will be converting your rows to columns to rows. Again I'm saying rows to column or columns to rows. So you can pick anything. If I'm picking a row, that becomes a column. 1 2 3, it used to be a row, now a column. If I'm taking another row again, then that would be like 4 5 6. The 4 5 6 used to be a column, now row, now it is a column. So this becomes 3 cross 2 matrix. You can see it is getting transposed, right? So what mostly we are trying to do here, okay, suppose what you are having, I'm saying I'm having a college student data. Okay, I'm having a college student data. In this college student data, what I'm trying to say, my student ID, and I'm having his math mark, I'm having his science mark, I'm having it English mark, all those marks I have. So what are the scores they have done? So if I'm having a vector and B vector, their scores are, let's say 80, 70, 85, and he is having 80 or 60, 85, that's 75. So if I will look into closely, my rows are students, right? See closely, I don't want to say anything. My columns are nothing but a kind of subjects. Yes or no? Kind of subjects. So if you will be looking properly how these things looks like, what I'm trying to say, if I will be transposing, after transposing, what the thing becomes, the columns becomes the, what will happen, we'll be recognizing like people like the what, it will be changing, right? This will be changing to this will be changing to this. That is what it will happen, right? Any doubt? This is nothing doubt, right? So it will be switched. So switching means what? You will be having something like this. See this. You're having math student ID. Hey guys, are you guys are still confused or what? No, you are not confused, right? You can convert it, right? You can see, right? Guys, you can see, right? So you can check it out, right? I'm leaving it to you guys. I don't want to write it these simple things, right? Okay. What it will happen when you'll have a matrix like this, a matrix, and if you'll be looking into closely, if a matrix multiplying with another transpose of it, what will happen? What do you think will happen? So in AI, mostly what will happen, transpose mostly happens like this. What does that means? This is nothing but, I can write like this or not, small a, or not small a, I'll be writing small b. Okay, isn't it something looks like linear regression? Okay, again I know you don't know about linear regression, I'll be discussing about it, but always remember transpose means flipping of things. Okay, flipping of rows and columns. That is enough to understand anything. You don't go that much of it. Again, you will be confusing what is linear regression. Yes, I know stuff. That's why you are thinking, okay, he knows. That's why he's talking. If you are starting with mathematics and statistics, just understand what is happening. And this example is also nice to have, right? Okay, what about this? Okay, there is something called, there is a catch to it, something called matrix power. Matrix power, the sixth point is matrix power. Matrix power, why I'm writing it down, at some point I want to share this document with you guys. So hopefully after completion this whole video series, I will be sharing the drive link and you guys can access it. By the meantime, you can write it down along with me so that it will be very useful for you guys. So if I'm writing a square, it will be a dot a dot a q, which is nothing but a dot a dot a. So that means the more power you will have, the more multiplication you will have. So what is that mean? Repeated multiplication is happening. So matrix powers means what? The transformation which we are doing. So what is a dot a means? It's nothing but transformation, right? I can say it is a transformation. So if I'm saying matrix power is nothing but it's a transformation of, that means transformation happening, same transformation, same kind of transformation is happening, because that same element is getting multiplied again and again and again. So same kind of transformation, I can say same kind of transformation happening. Okay, I don't want to say again what is transformation, right? Transformation is nothing but changing current situation, we are changing into something else, right? Now if I'm saying I don't want to again if I don't want to complicate things. This is good enough to explain. Multiplication you will be doing one by one. Okay, you will be doing this. Once this will be done, you will be doing with this according to your choice. You can go with this one, but right side multiplication will be making more like sense. But because these values are same, it makes no sense. You can go from right or left. Okay. And what about identity matrix? There will be something called identity matrix. Identity matrix, you I used to love this matrix because it is the easiest matrix to do it in college time. So identity matrix is nothing but your I represent I means identity is nothing but 1001. So what does that mean? Your column which is a diagonal, your diagonal column will be 1 always. Everything else will be 0. Okay. If we will be looking closely, there are two diagonals, this one and this one, right? I'm talking about the main diagonal. This is my main diagonal element. Okay, diagonal elements are equals to 1, others are 0, others is equals to 0. This is the main thing. So what will happen if the identity matrix geometrically it does nothing, right? Because if you will be seeing closely, it has no changes, right? It is just constant value which is 0 and 1, right? It will be in same position. What does that mean? If you want to see if I'm having a identity matrix multiplying with a vector, okay, it will nothing but the same vector will come. Yes or no? You want to see it out? Do you want? You can try it out. Okay, a vector 2 3, and I'm saying identity matrix is 1 0 0 1. If you multiply with 2 3, this is what? See this is a 2 cross 2, this is a 2 cross 1. What will happen? It will come as a 2 cross 1. So 2 cross 1 is nothing but a vector again, nah? So you will be saying 2 2, it will come like this only, 2 cross 1. So I am saying na, the identity matrix, when you will be multiplying a vector with identity matrix, it will be in same position, same direction, it will be there is no changes in angles as well, like minus plus, and also same length. If we will be doing length means magnitude. Remember, in a vector 2 3, its magnitude is nothing but 2 square plus 3 square root over Euler's distance, L2 mag, L2 norm, right? 4 plus, last video we discussed about it, just check it out. 4 plus 9, 4 plus 9, 9, right? 30 root over 30. Guys, it's very easy thing, you just try to do it out. So wow, how these things is going to be impacting, or how are the use cases of it. So think about it. You have a photocopy machine, right? Xerox machine. If you have a Xerox machine, I can say Xerox machine is the best example. If you're having a Xerox machine and you have a default settings, okay, default setting in a Xerox machine, you have a default setting. The default setting says like your scale should be 100%. That means 100% visibility with clarity. Rotation should be 0. Obviously you don't want to rotate your image, right, while you are photocopying it. 0 degree, then 0 degree, then Celsius. What I am writing Celsius, then I am writing translation. If it is in English, whatever it is written, it should not be there, right? Translation should be 0. So what is happening? I'm not changing anything. Nothing is changing, right? Because that scaling 100% is actually it's going to happen, right? So identity matrix means nothing, literally nothing. Okay, whatever rest of the operation is there, we will be covering it in the next one, because the next one will be little bit bigger than inverse one. Hopefully you guys liked it. Just like, follow and subscribe. Jai Jagannath guys. See you in the next video.